everybody again. So today we're going to be dealing with extreme values. Let's start. Sometimes you may find that your collection of data contains values that are extreme in some way. For example, if you were to measure the speeds of cars as they pass a certain point, you may find that some cars are moving unusually slowly or unusually quickly. It is also possible that you may have made a mistake and measured the speed incorrectly or just written the wrong numbers down. Suppose the following are speeds of cars passing a particular house over the 5-minute period, measured in kilometers per hour. One particular value will catch your eye immediately. 128.9 kilometers per hour seems somewhat faster than any other car. How does this extreme value affect your averages? You can tell yourself that the mean of the above data, including the extreme value, is 70.7 kilometers per hour. This is larger than all but one of the values and is not representative. Under these circumstances, the mean can be a poor choice of average. If you discover that the high speed was a mistake, you can exclude it from the calculation and get the much more realistic value of 59.0 kilometers per hour. Try the calculation for yourself. If the extreme value is genuine and cannot be excluded, then the median will give you a better impression of a main body of data. Writing the data in rank order. The median is the mean of 58.3 and 65.0, which is 61.7. Notice that the median reduces to 58.3 if you remove the highest value, so this doesn't change things a great deal. There is no mode for these data. Work example 1. After 6 tests, Graham has a mean average score of 48. He takes a 7th test and scores 83 for that test. What is Graham's total score after 6 tests? What is Graham's mean average score after 7 tests? So, since the mean equals the total of all data over the number of values, the total of data equals the mean times the number of values, which is 288. The total of all 7 scores was the total of 6 plus 7, which is 288 plus 83, which is 371, divided by 7, and you get 53. Exercise 12.1. For each of the following data sets, calculate the mode, the median, and the mean. So, that's 4 data sets with quite a lot of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers for A and D and 10 numbers for B and C. Well, let's calculate it. So for A, the mode, median, and mean are 12, 9, and 8. For B, they are 8, 6, and 5.7. For C, it is 2.1 and 8.2, both showing up twice. The median is 4.15, and the mean is 4.79. For D, the mode is 12. The median is 9. And the mean is 5. And the mean is 11.7. Question 2. Look carefully at the list of values in part A and D above. What is difference? How did your mean, mode, and median? How did your mean, median, and mode change? So here, the differences between A and D is that D has is that D has a number 43. That's a high number, while A only has a number 10, which is normal. Well, it didn't change the mode or the median, but it did change the mean. Here the mean is 8, and here the mean is 11.7. Question 3. Andrew and Barbara decide to investigate their television watching patterns and record the number of minutes that they watched television for 8 days. Find the median number of minutes spent watching television for each of Andrew and Barbara. Find the mean number of minutes spent watching television for each of Andrew and Barbara. So, Andrew's median is 54, Barbara's median is 48.5. But the mean is higher than the median, a lot higher, as Andrew's mean is 84.25 and Barbara's mean is 98.875. Question 4. Finalists of 5 numbers with a mean that is larger than all but one's numbers. So you just need to choose 4 small numbers like 1, 2, 3, and 4. And just choose a huge number, like, say, 1,000,000. Done. That might be too big of an extreme value, but it never said how big it could be. Question 5. A King 10-pin bowler plays 5 rounds in one evening. His scores are 98, 64, 103, 108, and 109. Which average will mean a median will he choose to report to his friends at the end of the evening? Explain your answer carefully, showing all your calculations clearly. So, there is no mode. The mean is 96.4, and the median is 103. So, I think that he would report to his friends the median, because it's the highest of all. If the mean height of 31 children is 143.6 centimeters, calculate the sum of the heights used to calculate the mean. It is 4,451.6 centimeters, which is around 44.5 meters, but you don't need to know that. Question 7. The mean mass of 12 bags of potatoes is 2.4 kilograms. If a 13th bag containing 2.2 kilograms of potatoes is included, what would a new mean of the 13 bags be? Well, it will be 2.38 kilograms. Question 8. The mean temperature of 12 cups of coffee is 89.6 Celsius. Degrees Celsius. The mean temperature of a different collection of 20 cups is 92.1 degrees Celsius. What is the mean temperature of all 30 cups of coffee? Well, the mean temperature is 91.2666666666 degrees Celsius, with an infinite number of 6s. 9. Find a set of 5 numbers with the mean is 5, the mean is 4, and the median 4. The mean 5, the median 4, and mode 4. So let's just say it is 3, 4, 4, 6, 8. Find a set of 5 different whole numbers with a mean 5 and median 4. No, it doesn't need a mode of 4 or any mode. Let's say 2, 3, 4, 7, 9. Question 11. The mean mass of a group of n boys is x kilograms, and the mean mass of a group of n girls is y kilograms. Find the mean mass of all the children combined. So the total mass of all the boys is mx, and the total mass of all the girls is ny. And the total amount of boys and girls is n plus n. So the answer is mx plus ny over m plus n. So, that's the end of this video. Thank you and goodbye.